W, so it starts going forward. I can press A to go left, let's see, and then press D to right, and then if I press W again, it straightens. Go backward. We're going to use this as a video car where we can drive this, slow it down, speed it up, turn left or right, and if we want, we also can take picture from command line. Hi, welcome to a product tutorial by Robojax. This is SunFounder's PICAR-X Raspberry Pi self-driving robot car kit.
Hello friend, how are you? Turn left here. Count down to 3 seconds. 3, 2, 1, rock. I lost.
If I press W, so these two keys, W means forward, S means backwards, A means left, and then D means right. And so let me press W, so it starts going forward. I can press A to go left, let's see, and then press D to right, and then if I press W again, it straightens. Go backward, it started, and F, that goes forward. And if I press F, it will stop. So F is closer here to stop. If I press again, nothing happens. So forward, backward, F, stop. Now, if we want to take a photo, I press T. The picture was taken. When you come to docs.sunfounder.com, you will see this page. Scroll down. Under the robot kit, you will find PICAR-X car kit version 2 with battery. Click on that. On the left side, you will see different options. Select Play with Python. And all our lessons are listed here. We will proceed from here. If you come to the documentation page, under the Python, click number 11, video car. And here we have some explanation what it does. And we are going to use this code 11.video_car.py, which is located inside example inside PICAR-X. And we have some shortcuts here. For each key, we can speed up, slow down, go forward, backward, turn left, right, stop, and if we want to take a photo, we press T. To quit, we press Ctrl C. The video also can be watched over the browser, but we cannot send the command to this address. And here is the code, which I am going to explain it fully. Now let me explain the Python code for the video car. From utilities, we are importing reset microcontroller unit. We are from PICAR-X, we are importing this class and vision library, sleep time, string format, local time, and then read character. This is for keyboard, and these are for naming of the file, and this is for vision library for the camera, and this is for the control. This is our manual. This is a variable that's holding all these texts to be displayed on the screen. We are using the PiCAR-X class, creating an object called PX, and this method is taking the photo, and I'm going to explain it. And then we have another method called move, which starts from here up to there. So this is all about moving, and this is the main one, which runs up to here. And this one will run the main from, it starts from here, and if there is an exception, it will print the error, and finally it runs the stop and closes the camera. Finally, it runs the stop and closes the camera. Now, when we call this function take photo, we create a _time variable from string format from time. So we are getting the time. This is a local time when we are creating a new string, year, month, day, hour, minute, and second. So the photo we take will be unique. And then at the end of this time, you see before this time we are appending photo _ photo and then the time. So this will be added. So before this time we are adding the word photo, and this is the path for the photo to be taken. We are taking the username, which is Pi home, and then it will be Pi, and then inside that will be picture PiCAR-X, and then we will put the name so it can be saved. Now to take the photo, we use a vision library, take photo, and we pass the name for the file here, which we created from all this information from these two lines, and then we pass the path. So it goes inside this path and saves it with this name. And it will also print the name on the screen for us as well. Now with the move, when we call the move, we receive one operating string and speed. And that string, if it is equal stop, we run px.stop. Else, we will look at it. If it is forward, we use the direction servo. We set it to 0, so the steering is forward. This portion, so the steering is setting forward, and then the robot will go forward with the speed that we pass. And then if it's backward, again the servo angle, for any reason, if it was left or right, it straightens it and goes backward with this method with the same speed. And if we have turn left, then the servo, this servo will run about 30 degrees to the left, negative, and then speed forward with the same speed that we pass. And if we have turn right, then with the 30 degrees, you see this was negative and this is now positive. This servo will rotate to the right, and with the same speed we go forward. Now with the main, initially speed is 0, status is stop, this is a string, and we initialize the camera. Camera start with vertical flip, because we can flip the video horizontally and vertically like that. So both of those are set to false. And then the display, this is for the browser. We are setting local display to true, and also web via browser. Both of these are set to true. And then we wait for 2 seconds for these to initialize, and then we print manual. When we call print and then manual, it comes and prints this manual, which is this text. This will be printed on the screen. After that, this is a while loop. Then while loop will run continuously. So this will run continuously. First, we print the status and the speed, because the status and speed are very important to know what is the speed and what is the, if it's moving or stopped, because we are looking at the computer screen and it's far away. Then we are using reading the keyboard, whatever key we have pressed, and then dot lower, it converts it to lowercase. So it doesn't matter if you press uppercase or lowercase a or p, and the result is stored in key. And here we check if the key is one of the values in these texts, W, S, A, D, F, O, or P. And here we check if it is equal O, then, and also if the speed is less than or equal 90, because it will be too fast. Then if it's less than 90, then we add 10, which will be 100%. Otherwise, it will not add it. If it is P, P is speeding down. So if it is P, then we check if the speed is greater than 10, then we subtract 1. Otherwise, it will not happen. Then we check if the speed is equal 0. Because we are reducing it, we should change the status to stop. And now we go to the direction, because if the key is not O or P, then else F. If it is W, S, A, or D, all of these functions will run up to here. All of them. So speed, if the speed is equal 0, we are setting the speed to 10, and then W. If W, then we check if the status is not equal forward and speed is greater than 60, then we set the speed to 60 and move forward. Else, if the key is A, then we set the key to the status to turn left. These keys have been arranged such that, so we put your finger and W goes forward and this S goes reverse, A should turn left and D to the right. So if it is A, we are setting the status to turn left, just the text is set to turn left. And then if the key is S and the status is not backward, because we are going backward, if it is not backward and the speed is greater than 60, then we set it to 60 and we change the status to backward. So by pressing the keyboard, we are just changing the text. Nothing else here at the moment, and speed. But the car is not moving. If the D is pressed, we change the status to turn right. So that is done. And then if the key is F, it means the status should be stop. And after this, we run the car, move. We call the function move with the status, which we changed here, and with the speed and status, both of these will be here. So we are passing it, and as I mentioned here, this move is executing all the code that we just called from here. And if we press T, then the take photo will run, which I explained it at the top. And if we press Ctrl and C, then we print quit on the screen, stop the car, and close the camera. Break. This breaks mean break from everything and the loop will not go. And when you run break, it will come to the finally and will run the stop and closes the camera. Even the camera was closed here. So this was a full explanation of the code. First, let's find out the IP address of our robot. Go to PowerShell, right click and run as administrator. And let's type ping -4 robojax.local. That is the host name that I set. IP address is 192.168.0.102. Open VNC player. We have shown you how to install it. And 192.168.0.102. Enter the IP address. You will get the warning, accept it. Enter your username and the password. I've selected username and password, and then click OK. Here is our screen. Go to the terminal Now let's see how we can run a program. When our robot starts, the program runs. I type dir, and we want to run this move program when the robot starts. To do that, we will go to the scheduler or cron job, sudo cron tab -e. So this is running as super user, as a root user, and then running the cron tab, that's the scheduler, and -e means edit. This is our file where you can write. The cursor is in here. I'm using the arrow to come down. You see it's here now. And in here we are going to write at reboot, and using Python we are running move.py, which is located inside example, PICAR-X, Pi, and home. So you have to write the full path. After writing it, press Ctrl O to write out, Ctrl O, and then enter to accept it, and exit, Ctrl X. I'm using Ctrl X. Now, after that, we click on this terminal and then type cd PICAR-X. I'm pressing tab to complete it, and then I type EX and tab to complete and enter. In here, let's check the list by typing dir, and we are going to run the video car, which is number 11. To run the code, we type sudo python 3 and then 11 dot, and I press tab to auto-complete it. Now when I run this, it will take some time. Pi camera 2 runs, and the servo straightens. To open it, so this is a video from our robot, and I'm going to use all these shortcuts. Let's put this somewhere here, and so we know all of this because all of side of the keyboard, and I'm going to try to put the other video in here so you can see the actual robot. Forward, stop, because it's hitting the wall. Let's go backwards. And as you can see, there is a lag in the video. Let's go turn left. And stop, because this is, oh, it already arrived to the cat scratcher. And then let's do straight and go back and stop, turn right and stop, left and stop. So we are at the same spot. Let's open and see the pictures. So if I press Ctrl C, the video is also closed and the program exited. Now here I have my laptop, so I can have the sense of screen, and I'm gonna use the commands to go forward, backward, reverse, and let's see. I'm going to send it now, forward, and then right. I'm holding it right, and let's see, and then forward, backwards, and left, back, forward, right, and then right continues, backwards, and then right. So it's just responding well. And I took the picture. That's the location of the picture, which I'm going to show you. Then go forward, right. I'm just going right now. So keep going, left, and then backwards. And now I'm zooming. Let's see, forward, backward, left, right. And that's cool. Backwards again. Let's check the picture that we took. I click on the file manager. Under the Pi home, we see pictures. And the picture has been taken in the PiCAR-X. If I double click here, that's the picture. Let's open it. And this was a picture that I took. Thank you for watching. I will see you in the next lesson.